Hi, this is Leetcode question, maximum number of points from grid queries. And this is the last question of weekly contest 323. You are given an n by n integer matrix grid and an array queries of size k. Find an array answer of size k such that for each integer queries of I, you start in the top left cell of the matrix and repeat the following process. If query of I is strictly greater than the value of the current cell that you are in, then you get 1 point if it is your first time visiting the cell and you can move to any adjacent cell in all four directions, up, down, left and right. Otherwise you do not get any points and you end this process. After the process, answer of I is the maximum number of points you can get. Note that for each query you are allowed to visit the same cell multiple times. Return the resulting array answer. So we have this grid and we have these queries 5, 6, 2 and 5, 4, 5. The answer is 5, and that's because there are 5 nodes that we can reach if we started from the top left, and these nodes should be less than 5. So at 1 you can travel right, this node 2, so until now we have 2 nodes. At 3 we have 3 nodes. 7 is greater than 5, so you cannot travel to 7, and from 2 you cannot travel to 5. From this 2 also you cannot travel to 5, but you can travel to 3. From 3 you cannot travel to 5, so in total you have these 3 nodes and these 2 nodes, so 5 points or 5 cells. This is why the answer is 5. For query 6, again we parse all the cells that are less than 6, so 1, 2, 3, 2, 3, 5, 5 and 1, so all the nodes except 7. This is why the answer is 8. 7 is greater than 6, this is why we cannot visit. And for query 2, the answer is 1, and this is because at this cell we cannot go to the right because 2 is equal to 2, and we cannot go to down because 2 is equal to 2 again. So only one cell we can visit, which is 1. 1 is less than 2, so the answer will be 1. And how can we solve this problem? As you can see here, for query 5 we have 5 nodes, and for query 6 we have 8 nodes. That part of these nodes is the answer from query 5. So 1, 2, 3, 1, 2, 3 is part of the answer of, or it's the answer of query 5, and also it's part of this answer. So we can take advantage of this by sorting the queries in non-decreasing order. So 2, then 5, then 6, and whatever we calculate for smaller value, we can take advantage of that for greater value. And to do that, first of all we need to sort the queries. So assume we have queries sorted, and this will contains both the values and the index. So this index is 0, 1, 2. So after sorting it will become, so we'll sort it by value, so 2 become first and the index of 2 is 2. Then we have 5, the index of 5 is 0, this is one pair, this is the second pair, then we have last pair 6, the index 1. We keep the index just to when we calculate the answer we need to know where to store it. And you see here the values are the query is sorted by their values. And here we need minimum or min priority queue. And why we need min priority queue? Because we are going to traverse the grid, and if the node that we pop from the queue is greater or equal to the current query value, we know that all the remaining nodes are also greater than the query value, and we stop for this query and store the answer. Then we move to the other query. Also here we have visited vector. It has Boolean values. This is just to make sure to not check the value multiple times. So first of all we store or we visit this value, so we push to the mini queue the value 1, which has index 0 0, and our first query is 2. Then we pop from the queue the value 1 is less than q. Yes, it's less than q, so we have a count. It started with 0. This is less than 2, so we increased this by 1 point, so the 0 become 1. Then we need to push to the queue because now this is visited. We mark it as visited, and we push all of its neighbors that are not visited. So this neighbor and this neighbor. Remember, we can go to right, bottom, up, and to the left, but here in this node we can't go to up and left because we should remain in the border of the grid. So we push to the queue the two neighbors 2, which has the index 0 1, and this 2 has index 1 0. Then we pop from the queue this value is 2. 2 is less than 2. No, it's equal. At this point we know this query is done, and we can store the answer, which is 1, into our answer. So assume we have another vector, which is answer index 0 1 2. So the first, or this query is at index 2, so at 2 we store the result, which is 1. And we set 2 equal to 2, and we are done with this query. So we move our index to the next query, which is 5. 2 is less than 5, yes, so we increase this count by 1. We have 2 points now, and we need to mark this node as visited. Also, we need to push all of its neighbor, going right, left, bottom, up. So this node we can go right, and we can go down. So to the right the value is 3, and its index is 0 2, and down the value is 5, its index is 1 1. Then we pop this item from the queue. This item 2 is less than the current query 5, so we increase the count by 1. The count becomes 3, and again for this 2 we need to mark it as visited. This is 1 0, so this value true, and again we need to push to the queue all the unvisited nodes 5 and 3. So 3 become 3 comes here, 3, and index is 3 0 and 5 1 1. Then we pop this node. This node is 3 less than 5. We increase the count, and again we mark this as visited, and we push all of its unvisited neighbor, which is only this one, going down. So this cube has 7 and its index is 1 3. Then we get this 3 from the queue. 3 is less than 5, so we increase the count by 1. We have 5 points. And again for this 3 we mark it as visited, and we push all of its unvisited neighbors. Here we can go to the right. We push the queue 5 and its index is 2 2 1. So 5 2 1. We pop this 5 from the queue. 5 is less than 5, no, and here we know that we have to stop for this query, and our result is 5. So query index is 0. We store 5 as an answer, and we move our index to the next query to calculate for it, and we take advantage from the last 5. So here 5 is less than 6, yes, so we increase this by 1, so to become 6. And then we have to push all the unvisited nodes. In this case it's 1, but 1 become at the top because it's priority queue. So 1 0 1 2 2 2. Then we mark this as visited. It's 5, which is 5 1 1. So this is visited. Then we pop this node. This node value is 1. 1 is less than 6. Increase this. Become 7. There is no unvisited node. Then we pop the next value, which is 5. 5 1 1. We already visit this node. Then 5 1 1. It's visited. Then we have 7 1 3, or we have 5 2 1. 5 2 1. This is not visited. Is 5 less than 6? Yes, so we increase the value by 1, become 8. Then we have 7. 7 is not less than 7 is not less than 6, so we know we have to stop our calculations here for this query, and we store the answer. So this will be our final vector 581, and as you can see it matches to what's given in the question. The time complexity of this is m but multiplied by n, and here because we have priority queue, so multiplied by log of m multiplied by n. Let's look into the code implementation. Here first we get m and n and k. K is the size of the query, and here this one will store the sorted queries. Call it queries values indexes, and we push to it pairs of query values and the index, then we sort it, and this vector will contain our final answer. This is our visited Boolean vector. Then this is the priority queue, takes the grid value and the index of the cell I and j, and this is queue index. Remember, here we start at index 0, then we keep moving. So this is our index, and this is the count. The count is here, the one we calculate, and we start with 0. So initially we push to the queue the first top left element, then we keep looping until the queue is empty, or until the queue index, or like we finish calculation for all the queries. And here we check if this node is visited, and if not, we mark it as visited. And while queue index less than k and vector of 0 greater than query value index of queue index dot first, this is to check if the value we get from the queue is less than the current query value. Other than that, we store the answer, and we keep increasing the index value until it's become smaller. Here we check if queue index equal to k. We are done, so we break count plus plus. It means that we gain one more point, and here we move into all the allowed directions by considering also if the nodes are visited. So here we go right, up and down, and left. Then here also we need to do another check, because it's possible that the queue is empty, but we did not finish our all our queries. In that case, we store all the remaining queries with the last calculated count.